Very good. Let's do 52. Maybe you want to choose a different type of function or equation. Maybe 53 or 54, because that's very similar, but it's up to you. I'll do more than one, of course. Which one? Yeah, let's do 52. Since you picked 52, that's fine. So we have X and Y, and this is, they give us 0 here, they give us 0 here, and they give us -3 here. Perfect. And the equation we are given is X equals -Y plus 4. Ready? So we are told Y is 0. Y is 0, I'm going to cover this term because it's 0, and I determine X to be 4. Same thing with Y equals -3. Put in -3 for Y and tell me what you get for X. How much? 7, right? So when I plug -3 in here with minus in front is +3. So if this is -3, the opposite of -3 is 3. 3 plus 4 is 7.
Oh, I got it. Can you go around again real quick?
We learned in chapter 2 to evaluate expressions, right? So if I have -Y plus 4 and I'm told that Y is -3, I have to put negative, I have to copy this. In parentheses, I have to write -3 plus 4. We know that the negative sign in front of a grouping symbol changes the sign, or -1 times -3 is +3, and plus 4 is 7. That's why we wrote 7. Is that okay, everyone? So now I'm told that X is 0. So I replace X by 0, and I get -Y plus 4. Can anyone solve this equation for Y and tell us what we get? 4 indeed. Because you move Y to the other side, so Y equals 4. Any questions? Bless you. Any questions? So I am told that X is 0. 0 equals -Y plus 4. -Y is moved to the other side, it becomes +Y. Y equals 4. Or you add for Y to both sides. It's up to you. Which one? 53 it is. In 53 we have Y equals 1/2 X. And the table is X, Y. And they are giving us 0, -6 on the X side, and they are giving us Y equals 1 on the right hand side. Let's work on this for 1 minute. Can anyone give us anything? When X is 0, Y is? Excellent. Do you all agree with that when X is 0, 1/2 times 0 is 0? Okay, very good. Now what about when X is -6? Do you all agree with -3? Okay, now I have to replace Y by 1 and determine X. How much? Do you all agree with 2? Very good. Excellent. Any questions?
So you get 1 for 1.
It was given in the table. I copied it from the book. So this was given to us. So when I plug in 1, I multiply both sides by 2 to get 2. So I have 1 equals 1/2 times X, multiply both sides by 2, 2 equals X.
Okay.
I have to eliminate fractions. Any questions? Any questions? Yes, go ahead. Any questions? Any questions?
We're gonna put this on the lecture. There. Those are the lecture points to put up. We're gonna have that up tonight. Or whenever you load it up.
You're talking about the scanning?
Right here. Yeah.
Always.
Okay.
I'm not behind with that. I'm behind with grading your homework, but I'm not behind in this because I recycle them. So
All right.
yeah, it may not be tonight, but it might be tomorrow morning. But it will. Yep, very good. Okay, I'd like to move on to graphing linear equations, and we have to talk about what a linear equation is. Graphing linear equations. A linear equation is an equation that looks like this. Exactly what we just found points for. Y equals 3x plus 6. Another example. Y equals 1/2 x. Another example. Y equals negative 3x plus 9. All these are linear equations. How do I know? How do I know they are linear equations? It can have, very good point. Let me give you another example. Thank you for saying that. 2x minus 3y equals 6. So this equation is still linear, but it's not solved for y. Very good point you're making. So how do I know that all these equations are linear or not something else? Some other type of equation. Here's how I know. So here's the reason. Or reasons, I should say. 2, in this case, x and y have power 1. Do they have power 1? Is this x raised to power 1? Is this y raised to power 1? And all of them, in all the other equations, x and y have power 1? Good. X and or y are not in the denominator. Do we see x or y in the denominator and something else on top of it in any of these equations? Okay, let me give you an example in which I have 1 over x equals 3y plus 2. Do I have something like this in those 1, 2, 3, 4? No. Something like this will not be a linear equation. So x and y cannot be in the denominator. X and y have to have power 1. Must have power 1. And no product of x and y. For example, x times y equals 10 is not a linear equation. So if an equation has a product of x times y, that cannot be linear. So no x and y in the denominator, no product of x times y, and the powers of x and y must be 1. That classifies these 4 equations as linear because these 3 conditions are fulfilled, right? X and y not in the denominator, no product of x and y y have power 1. That makes these linear. Okay. The graph of a linear equation is a straight line. Excellent. Okay, now here's what I would like to do next. I would like to graph 2x minus 3y equals 6. We'll graph the other ones as well. Or combinations, or we pick from the book, it doesn't matter, but I want to start with this. And I'm going to say comma, very important what follows now, using X and Y intercepts. Graph 2x minus 3y equals 6 using X and Y intercepts. What is that? So we have to talk about X and Y intercepts first. So here is a coordinate system. And the four possible types of lines are these, right? This is one possibility, going up from left to right. Here is another possibility, going down from left to right. This is a third case, which you already graphed it, and we haven't even talked about that, but specifically, but we already graphed it. What is this? Okay, let me remind you. We graphed it half an hour ago. What is it?
Vertical.
Vertical line. And we also graphed this. What is that? Excellent. Good. So now, looking at, I'm not graphing this yet. I'm discussing X and Y intercepts, what they mean first. So, looking at the following graph, please. Assuming I have this line. This is not this. Could be, but this is not what I'm graphing right now. I'm just discussing X and Y intercepts. So this is the x-axis, the origin, and the y-axis. Can anyone tell us what is the name of this point? What do you think?
3, 0.
The name of it. Yes, you're right. 3, 0. Excellent. This is the origin. Wonderful. This is indeed exactly the point where the graph crosses the x-axis. That must be the x-intercept. Very good. This is the origin. What do you think this is? Right. It's where the line crosses the y-axis. So this is the y-intercept. Perfect. So now, what did we say the equation of this line was? 0 is not an equation. An equation. Careful. It's the altitude. It has nothing to do with x. Y equals 0. Yeah? Very good. Please remember that. So then this point, out of those two coordinates, I know one for sure. Which one? 4. Exactly. What I don't know is this, and we will find it in a minute. Okay, what did we say about the equation of this line? So this is the y-axis. What is its equation? Okay. Careful. Yes. The y-axis has the equation x equals 0. Very good. So for this point, I know one of the coordinates for sure. Which one?
X is 0.
Very good. What I don't know is the y-coordinate. This is the way I will find the x and y intercepts for any graph. One more time. In order to find the x-intercept, I will set... Excellent. In order to find the y-intercept, I will set x equals 0. So please, let's write this down. This is crucial. To find the x-intercept, comma. I set, one more time. Say it again. Excellent. To find the y-intercept, I set x equals 0. So easy to remember. The y-axis is altitude 0. Always remember, y equals 0 is the x-axis. The y-axis is position 0 for x equals 0. So now I'm ready. Now I want to graph 2x minus 3y equals 6. Using the x and y-intercepts. So in order to find the x-intercept one more time, I set, good, all I have to do is put my finger on it because it's 0. Please tell me how much is x? Very good. What is the ordered pair that we just found out? And I have to say, x must be the first coordinate, y must be the second coordinate at all times. Very good. Now the y-intercept, please. What did you say I have to set? All you have to do is cover it. And please give us the y coordinate of the point. -2. Remember, x is first, y is second. What is the point that will be the y-intercept? That's why I write them without combining them, because that is the danger. How much? 0, -2. That's why after I determine the x-intercept, I write the point. If you wait, you may be tempted to write 3, -2, and you will never be able to graph. So please be careful. Always write the ordered pair after you determine it. So let's graph on the coordinate system. Can anyone tell us again what we have to plot first? And I will plot it. It doesn't matter. The order is not important, but I would have started with 3, 0. So 1, 2, 3, 3, 0. And the other one? I plotted the x-intercept. I plotted the y-intercept. All I have to do now is connect the 2 lines and the 2 points and extend the line. I have to write the name of the graph. And the name is 2x minus 3y equals 6.
So would you expect that on the test for those to write it on?
Yes, please. You will see later why we need that. Because we will graph more than one line on the same coordinate system, and we will not know which one is what. Any questions? Any questions? Any questions? Okay. I would like to graph 34 on page 191. Two x plus y equals 2. Again, the requirement is use graph using x and y intercepts. Okay. The x-intercept. How do I find the x-intercept for any graph? Very good. I said if y equals to 0, all you have to do is just cover it. It's gone. And identify x. X is, I have to write the ordered pair right here, right now, before I move on. Remember, X is always first, Y is always second. 1, 0. Now the Y-intercept, how do I find it? Yes, when X is 0. And how much is Y? 2. What is the ordered pair? X is always first, Y is always, yes. So now I'm ready to graph. What is the ordered pair that I have to plot first? This is the first ordered pair that I have to plot, 1, 0. And the second ordered pair is 0, 2. Excellent. At this point, I connect the two and I extend the line. Put arrows top and bottom, and somewhere next to it I write 2x plus y equals 2, so I know what I graphed.
So you got the shade on one side?
That is when we solve inequalities into variables. Yes. You're way ahead of me, which is good. Now I would like to graph x equals -3. What type of line is this? And I definitely don't need points for this. So how do I graph such a line? What does it represent? What type of line is it? Vertical line. Where?
On the x-axis.
At -3. This is the vertical line, x equals -3. What if I ask now, please graph y equals -3? How will you graph y equals -3? At?
-3.
So this is y equals -3. Now I would like to graph y equals 1/2 x. We're not solving for anything. We are only asked to graph. So the x-intercept. How do I determine the x-intercept? I make y equals 0. So the equation becomes 0 equals 1/2 x. How much is x? So that 1/2 times x is 0. Very good. What is the ordered pair that we just determined? Therefore, the line passes through the origin, and this point represents the x-intercept as well as the y-intercept. One point is not sufficient to graph a line. Here's why. Here's why. If I have this point, how many lines can I draw through it? But what about if I have 2 points, exactly 2 points? How many lines can I draw through 2 points? That's the reason why when I graph a line, I only need 2 points. Can I find 10? Yes. I will waste my time though. I only need 2. So I have to make up another point. But I cannot say x is 5, y is 9. No, 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 no. I have to pick one value. Let's say x equals, if you say 3, it's going to be kind of difficult to plot. You should say 4, okay. When x is 4, I plug in 4 and I determine the corresponding y value, which is 2. What is the ordered pair that we just determined? 4, 2. Now I'm ready to graph the line. The 2 points, what is the first point you will plot? Yes? What is the second point you will plot? 4 for x, 2 for y. The intersection is right here. I connect the points and extend the line. Uh-oh. Shaky hand. I write the name. The name is its equation. 1/2 x.
So you're saying if you come up with 0, 0, you just make up a number?
I don't.
Where-
I pick an x value and I calculate the corresponding y value.
You just make up a number for x.
I pick a number, yes. I pick a number for x, but I don't pick a number for y. If I pick a number for x, I have to calculate y based on that particular x value. So when I plug in x equals 4, I get y equals 2.
Can you do another one of those?
Sure. Very good. Any other questions here on this?
Not yet.
Okay. So let's say we want to graph negative 2y equals x. Okay. So the x-intercept. How do I get the x-intercept? I make y equals 0. So how much is x? What is the ordered pair that I just determined at this step?
0, 0.
Good. Therefore, the line passes through the origin. The x and y intercepts are the same point. I need another point. So it's up to you. You can say y equals, or you can say x equals, but not both.
Pick a number for x.
Okay, we want to pick a number for x.
5.
No, that's not a good number because then you have to divide 5 by negative 2. It's okay, but it will be more difficult to graph.
6.
6 will be good. Because if you say 6, then I have negative 2y equals 6, so then y equals
3.
negative 3. So then the ordered pair that we just determined is
0,
this was done. You cannot connect this. It's already done. It's closed. I have the point. It's done.
Oh, 6 and negative 3?
Correct.
All right.
Very good. So then I will plot the origin because that's the first point. Okay, this is x, 0, y. And then the other point will be, one more time, 6 for x and
Negative 3 for y.
negative 3 for y. And here's the point. I will connect, extend, write the name. And the name is negative 2y equals x. Any questions, please? Any questions? Any questions?
X, what's X marked at negative? Well, what's marked at 5? See how you plotted it? It's 3 at the bottom for y. Negative 3. So where's your 6 at? Plotted at.
1, 2, 3, 4. Oh!
Okay, got it.
Yes. 1, 2, 3, 4, 5. Oh, so
Six.
sorry. So sorry.
Okay.
Wow. You're right. I said 6, but I didn't go far enough. Good catch. Sorry, that's not what I meant. I meant 6.
Okay.
Sorry about that. Very good. Good catch. Any questions? Any questions?
You said you're gonna upload all of this so we can how to do it
Absolutely.
tomorrow? Okay.
Yep. I want to look at problem 70 on page 201. The price of admission to a movie theater has been steadily increasing, and we know that, right? The price of regular admission Y in dollars to a movie theater may be represented by the equation. Y equals 0.24x plus 5.28, where x is the number of years after 2000. X, number of years after 2000. And Y is the price of regular admission. Y in dollars. Y in dollars, price of regular admission.
So is Y gonna equal 528?
This is the equation of a line, and it's 0.24x plus 5.28, where x represents the number of years after 2000, and y is the price for regular admission. Let's see what they want from us. Find the x-intercept of this equation. Part A. Find the x-intercept of this equation. How do I find the x-intercept? Very good. I have to, for the x-intercept, I have to set y equal to 0. So please dictate the equation you will solve for x, and I will write it. Yes? Yes?
0.24x plus 5.28.
Excellent. How do I solve this equation for x?
Move x to the left.
Yep, you could move this. So this is going to be negative 0.24x equals 5.28.
Let's divide now.
Now I divide both sides by
24.
negative.
24.
Negative. 5.28. Good. Grab my calculator. 5.28 divided by 0.24. 1.167. So x equals 1.167. Or 7/6. Or. Okay. Can anyone give us the ordered pair that represents the x-intercept? Right, or 7/6, comma?
Yeah. And the other one, the y would be 0.
Absolutely. Part B. What does this x-intercept mean?
No, yes, there.
Year 2000, moving prices were 1.1.
So remember, so in the year 2000, that represents x equals 0. Because we are told x equals the number of years after 2000, right? So x equals 0 represents this. Oh, remember, it's a negative. It's negative.
That's what I was gonna ask.
Yeah, just make sure. Okay.
That time was always.
True. True. So this means how many, did I divide this incorrectly?
That's what I was about to say.
Oh, yeah, I'm sorry, my calculator, for some reason when I turn it on, I have to wait for a few seconds because otherwise the first number that I type in, it doesn't take it.
It's gonna be negative 22.
Sorry about that. 5.28. Yes, okay. Divided by 0.24 is negative 22. Sorry about that. I just divided something else. Sorry about that. Thank you. Thank you. So x equals negative 22. So the ordered pair is negative 22, comma 0. So when x equals 0, the year is 2000. When x equals negative 22, what does that mean? If x equals 0 is 2000, what will mean x equals negative 22? 22 years before 2000, right? So 19, good. So what does the ordered pair mean? That in 1978, according to this model that they gave us, how much was the cost of the admission to the theaters? How much? according to the model. How much? How much? Right. Right. So that's the y-intercept. Remember? Let's go back here. Right? This is the y-intercept. When x is whatever, I'm sorry, when x is whatever, y is 0. Okay? Perfect. So I would write in 1978, according to this equation, the price for a regular admission in 1978, according to the model, or to this equation, the price for a regular admission was, because y is the price, x is negative 22 years before, was $0. In part C, use part B to comment on your opinion of the limitations of using equations to model real data. So here's the answer. I have to look at the range of years where, because based on a certain range of years between 2000, let's say, and 2010, they created this model. Outside of the model, outside of the range, I should say, I don't know if I can use the model. And certainly I cannot use this model for 22 years before 2000. So it is always risky to go outside of the range of the equation. So if the data that they looked at is between 2000 and 2010, you cannot use this model to predict 2050. You cannot use this model to look at 1950 as well. So that's the answer. Meaning, what does it mean? It doesn't mean anything, because the model was created for a certain range. And anything outside of the range, we cannot use the model. We don't know whether was the same model was true in 1978. We don't know.
No, we know.
Good. Okay, so I'll stop here for tonight.